Hello everyone, this is the last example that we have in that section, and I know we did that first part together, which is the equation, but I also thought that you probably benefit from also watching that second part of of the graphing as well. So we can go ahead and do that. So the first part was the new one, that's why we did it in class, but I'll go ahead and continue again. So let's get the equation first of. So we start with this equation 4x squared plus 9y squared plus 16x minus 36y plus 16 is equal to 0. And they told us it's an ellipse. So the general equation of an ellipse would be it has to have a form if the center is not the origin. So if the center is a point h comma k, then the equation of the ellipse would be something like this: x minus h squared over something plus y minus k squared over something is equal to 1. Now, depending on whether its major axis is horizontal or vertical, maybe you'll have here a squared and b squared, or they can be switched. Okay, but in any case, the general equation is going to have a complete square with the x and a complete square with the y, and that's what we are going to start with. And it also has to have 1 on the other side. So the first thing we're going to do is we're going to get all the terms that have x together in order to complete the square, and all the terms that have y together, and then all the numbers, the constants, we're going to put on the other side so we can get a 1 on the right hand side eventually. So reorganizing this, we have 4x squared plus 16x plus 9y squared minus 36y is equal to negative 16. That's the first step. Next, we're going to want to complete the square for the x values and complete the square for the y values. But for us, so far, we have been completing the squares for values where the coefficient of x squared or y squared is only 1. For example, if I have a x squared plus, let's say, 8x, for example, then I know in order to complete the square, I'm going to have to add 16 over here. Okay. But if I have a, 5x squared plus 8x, for example, we're not really familiar with what to do with this coefficient. So before we complete the square, just to make it a little bit more convenient for us, what we'll have to do is that coefficient of x squared and that coefficient of y squared, we're going to factor it out in order to make the coefficients equal to 1. So from the x squared one, I'm going to factor, or from all the terms that have x, I'm going to factor out a 4. We're going to factor out this 4, which then gives us x squared plus 4x. And now I'm going to go ahead and leave a blank space here so I can complete the square for the x's. And I'm going to do the same thing for the y's. I'm going to factor out a 9, so plus 9 times. And then I have y squared minus 4y. And then I'm also going to leave a blank here to complete the square for the y's. Is equal to negative 16. Okay. So now let's complete the square now. So in order to complete the square for the x's, I'm going to have to add 4 here. Now remember that whatever we add on the left-hand side, we also have to add on the right-hand side. Okay, so if I added something on the left-hand side here, I have to add it to the right-hand side to keep the balance. But here's a common mistake. We did not just add 4 on the left-hand side. because remember that you had already factored out a 4 here. So essentially what happens if you distribute that 4 back in here again, you don't just get a 4 that you added, you actually get 4 times 4, which is 16, and that is what we just added on the left-hand side. So even though it looks like we just added a 4, in essence we added a 16 to the left-hand side, and that's what we have to add to the right-hand side. So this is a trick here that's worth paying attention to. Plus, let's do the y. So y squared minus 4y. Also, we need to add a 4 to complete the square, but exactly same concept here. We didn't just add a 4 on the left-hand side, we added 9 times 4, so we added a 36. And that's what we have to add here to the right-hand side. Okay, so now we can complete the square. So we get 4 times x plus 2 squared plus 9 times y minus 2 squared is equal to, the right hand side now, the 16s are going to cancel, so we end up with 36. Okay, we're almost there, guys. So now if you look at what we need to do, now we have a complete square here, a complete square here. We just need to get 1 on the right hand side. So we're going to divide both sides by 36 in order to get 1 here on the right hand side. Okay, so we would have x plus 2 squared divided by, so if I divide this by 36, then this 4 is going to cancel with the 36. I'm going to end up with a 9 here on the bottom. So this is going to end up being x plus 2 squared divided by 9 plus. Same thing here, if I divide this by 36, the 9 and the 36 will be simplified, and I'll end up with a 4 here on the bottom. So it's y minus 2 squared divided by 4 and dividing by 36, so I end up with a 1. So now after doing all that, we just got our equation for this ellipse. Let's go ahead and get everything else and also graph that ellipse. So x plus 2 squared over 9, y minus 2 squared over 4. So here's the equation. Okay, and let's go ahead and kind of list what we know about this ellipse from the equation. First of, again, this is x minus h squared, and this is y minus k squared. So we know that the center, which is h and k, is going to be -2 and a +2 here. Notice also that the denominator of the x squared term is the bigger one, which means this here is our a squared and this is our b squared. And since the denominator of the x squared term is bigger, that means our major axis is horizontal. Okay. And we can also tell that A is equal to 3 and B is equal to 2. Okay, so this is what we can figure out from our equation. So we can go ahead and attempt to graph this. Okay. I'm going to do my best not to butcher this graph. All right, so let's put the points that we know. We know the center is going to be the point -2 and 2. So -2 and 2. So the center is going to be right here. So this is our center, that point. We know that the major axis is horizontal. So the major axis is going to go through the center, and it's going to be this. So all the other points, the vertices, the foci, all of them are going to go on this one. So this here is our major axis. Okay, we also know that A is equal to 3, and A is the distance from the center to the vertices. So if I start from the center and I'm going to go 3 in each direction, so if I go 1, 2, 3 here, that gives me our first vertex, so I'll call it V1 at this point. And if I go 3 on the other direction, 1, 2, 3 right here, that gives us our second vertex. So we can actually go ahead and write that down. So vertices are going to be the point, so V1, that's going to be so -3, -4, -5. So that's going to be the point -5, 2. And the other one is the point 1, 2. All right. The other thing that we found out is that B is equal to 2, and remember that B is the distance on the minor axis. So from the center, we can extend this minor axis up and down. Okay, so this right here is our minor axis. And B is equal to 2, so we're going to go 2 points up here. So right there is the first point on the minor axis, and if I go down 1, 2, right here is the other point on the minor axis. And we can go ahead and write those down. So the 2 points on the minor axis are, so the first point down here is going to be -2, 0. And the one on top here is 1, 2, 3, 4. Okay, so that's -2, 4. And since we have now the 2 vertices and the 2 points on the minor axis, we can actually go ahead and we can now graph our ellipse. That's all we need to graph it. Okay, so that's what our ellipse is going to look like. And now the only thing left for us to find are the 2 foci. And in order to find the foci, we need to find the distance C, which C is the distance from the center to the foci. So let's find C, and we know that the relationship between A, B, and C is A squared is equal to B squared plus C squared, which means that C is going to be the square root of A squared minus B squared. So A squared, that's going to be 9 minus 4, which is going to be the square root of 5. So that's what C is, which means it's about, it's a little over 2, you know, so I think it's approximately 2.2 if I'm not mistaken. And I'm approximating this so I can know exactly or know approximately where to graph it. So from the center, if I want to find the first focus, I'm going to go 2 and a little bit more. So somewhere over here, this is going to be the point F1. And if I go the other side, I'm going to go 1, 2, and a little bit more. So over here, that's going to be the point F2. So these are the two foci. Last thing I need is to go ahead and find their coordinates. So the coordinates for F1. All right, so here's where we have to start with. So I know exactly where the center is. So this here is -2 on the x-axis. That's where that center is. And I know that this distance from the center to the focus, I know that this is a square root of 5. Okay, so if I go, so I need to find, so to find the focus, I need the x coordinate, which should be this distance, and then the y coordinate. And the y coordinate, I know it to be 2. So I know this is going to be something comma 2, and that something is this distance right here. What I do know is from here to here is -2, and then I have to go another negative square root of 5 to the left. Okay, so the x coordinate for the point F1 is going to be -2 and then minus another square root of 5. And that's the x coordinate. -2 minus root 5, and the y coordinate is 2. So that's this first focus right here, F1. Okay, next I need the coordinates for the second focus. And again, our reference here is going to be the center, because I know that I go -2 that way. But in order to reach this point, I know that this distance is square root of 5. So I go -2 and then I go that way square root of 5 in order to reach my point F2. Okay, so essentially it's -2 and then plus square root of 5. Okay, so this is the point -2 plus square root of 5, and then the y coordinate would be 2. And now we have all the pieces for this problem, and we are done.